Hello, and welcome to this session. My name is Magda. I'm a Scala developer at Software Mill, and I'm very happy to be able to talk to you today about one of my favorite subjects. But to be honest, when I first heard about property-based testing, I wasn't too impressed. It was during my first months writing Scala, where everything was new and confusing, when I noticed that each Scala project that I join has this thing called property-based testing somewhere inside. And at first I thought, that's just another Scala thing. So I will get to do the same thing that I already know how, but I will have to relearn it to do it the Scala way. But when I actually sat down and understood what it's really about, then I thought, whoa, now that's something pretty unique. That really changes the game. And the reason why I thought that is because with property-based testing, it's your role as a developer to define some properties about your code, but it's the role of the library to actually find the bugs for you. So actually it's the library which does some of the job for you. So I thought, that's a good idea. But my second thought was, wait a minute, why am I learning about it only just now? After all, you can easily apply this concept outside of Scala, outside of the world of functional languages. So today I would like to do just that. I would like to tell you that property-based testing exists, that it's pretty unique, and that if you haven't already, that you should really consider trying it out next week. So let's start with an example. Let's say that we have some code that we would like to test. It's our business method which calculates a discount for our customers. So the logic inside that I want to show here is that for a customer who has been with us for between 0 and 1 year, so less than 1 year, they don't get a discount. If they're with us for between 1 and 2 years, they get 10% discount. And if they're with us for over 2 years, then they get 20% discount. The method returns a big decimal, so we encode it as 0.2 and so on. And just to make it extra difficult or just to add some complexity, let's say that if it's the customer's birthday today, then they get a special 30% discount. And let's say that this is our method signature, so we have implemented this calculate discount method, this is our customer type, name, dates, and so on, and we would like to test it. So first, let's see how we would test it traditionally. So as opposed to property-based test, let's call traditional test example-based tests. So how I would go about that would be I would at first think about the happy path. So what does the method do? It calculates discount. So let's prepare a test case verifying that the method should calculate 10% discount. So I would prepare an instance of the customer class, invoke my business method, and then verify with an assertion that it's actually 10% or 0.1. And I would also prepare a similar test case for 20% discount. So again, an instance of customer, invoke my method, and verify that the result is what I expect. And let's also prepare a test case for the birthday discount. So I would prepare a customer who has joined, let's say, 20 years ago, so the day and month is the same as the current date, and verify that they get 30% discount. So far, so good, but of course we know that's not enough. So we also have to think about edge cases. So what edge cases could there be? Well, we could make sure that the method should calculate no discount for a customer who has joined just now. So I would prepare an instance of customer who has joined now and verify that their discount is actually 0. And we can verify the other thing on the other edge. So we want to make sure that the discount doesn't grow indefinitely, so that if the customer is with us for 10 years, they don't get 100% discount. So let's prepare an instance of customer who joined 3 years ago, and let's verify that their discount is only 20%, so 0.2, if they don't have a birthday today. So if I had such a set of test cases, then I would think, good job, I've got the happy path verified, I've got the edge cases verified, so commit, push, and just move on implementing some other feature. Now, how is it different in the world of property-based tests? So what are those properties anyway? So as I mentioned, these are the kind of properties, assumptions, or rules that have to be true if your code is correct. So that's something that you have to specify according to your unique code. And then the library will verify if it's always true, if this property is always correct. So no matter what input data you put to your method, the output data has to follow that rule that you have defined. And the library is guarding that for you. So what kind of properties could we think of here in this business method that we're writing? What has to be true for all of the customers, all of the dates of when the customer joined and the dates of now and their date of birth? We could say, for example, that the discount is never less than 0. No matter what crazy data is in the input, the output is always 0 or more. So that's the kind of property that we could write. But you may say, wait a minute, this doesn't really verify it in 100%, because you can have code which behaves incorrectly, but which would follow that rule. And yes, you are right, but it's not so much of a problem in property-based testing. Because one thing you could do is you could add more properties. So for example, you could add another property verifying that the discount should never be over 30%, no matter what data is there in the input. I know it still doesn't cover the 100% of the algorithm, but that's fine. You would also always have some example-based tests, some traditional tests to verify the concrete examples that they're still correct. But you can think of property-based testing as defining some kind of sane boundaries. And within those boundaries, your output or your code has to behave. The result has to fall into those boundaries. And the library will guard that for you. However, can we define some more libraries, some more properties for that, some more sane boundaries? We could test the customers together. So we can say that the discount should be proportional to membership years. So we can say that for all 2 customers, of which one of them is longer with us and the other one is shorter with us, then the one for the discount for the longer the customer, the older customer, is greater or equal to the other one. And with that assumptions, the output has to fall within those boundaries, within this property that we define. And similarly, we can test the birthday discount using 2 customers. So taking the data, asking the library to generate the data which has 2 customers and one of them has a birthday, the other one doesn't, then the discount for the birthday customer has to be greater. Now, let's see one of those properties written in code. But before we look at the code, let's say a couple of words about libraries. Because if it's the role of the library to do some of the work for you, then the better library you choose, the better work it will do for you. And property-based testing has been around for a while. And actually, there have been implementations in many different languages. And among that, for example, the Scala implementation is quite good, quite mature. But also the Java implementation, the Java libraries are quite good. So if you don't choose a good library, then chances are that it will only support you just a little bit, but it won't be so smart in supporting you. So here in Java, there's 2 libraries that I especially recommend, JUnit QuickCheck and JQuick. And JQuick is the one in which I will prepare the examples. So all the examples are in JQuick, but all the concepts that I talk about can be easily found in all other property-based testing libraries and in all other languages that support that. So let's see the example. The body of the method is pretty normal. So we invoke our method and then we verify with an assertion that the discount is not more than 30%, because this is the property that we would like to test. Here at the top, you have some annotations. So the property annotation just tells JQuick to discover this test as a property-based test. But all the magic happens here, in those 4 all annotations. So what you're saying is you are saying, dear JQuick, here is my property. Please verify it for all customers and all future dates, all dates. And what JQuick does is it generates 1,000 pairs of random data and runs your test again and again, 1,000 times, to verify that this property indeed was true. I said random, but it's actually something much more than random. It's something that I like to call nasty randomness or tricky randomness. Because actually a good library will have some heuristics which will try to define data which is more likely to break your code. So if you imagine working with strings, then for sure from the library you would get sample data or test data, which are empty strings, very long strings, various char sets mixed together and so on. If you are working with numbers, then expect 0, minimum and maximum number from the range, and so on. If you are working with lists, expect empty lists, very long lists, lists which contain the same element copied over and over again, and so on. So the smarter the library, the more tricky data it will generate for you. So what happens if it actually, for one of those 1,000 runs, it finds that the property is not true? jQuick will print a lot of useful data for you, but let's look at it from the end. So here, this original sample is the actual sample data which jQuick found that for this sample, your property doesn't hold true. But actually, jQuick doesn't stop that. It tries to simplify this example so that it's actually easier for you to spot what the actual problem is. And that's called shrinking in the world of property-based testing. And it's something that the library can do very well, or it can be pretty basic at. So can you see here from this example what was the problem in my implementation of the discount method? It's the 29th of February. So leap years. So actually my implementation didn't take into account leap years, and somewhere in the calculations there was some exception was thrown. And this is exactly the kind of thing where property-based testing shines at. So I thought my code was well tested. But what we usually do is we write our code with a couple of concrete examples in mind, and we write our test code with those examples in mind. So we're kind of biased. We have kind of a tunnel vision. And the library is not biased. The library will try to search for data which is tricky and which will break your code. So this is where property-based testing gives you the value that no other kind of test can give you. So where does it really take the data? If we are working with simple types, then you will get the generators out of the box. Generator is the source of the data, the tricky data for your test. So for strings, numbers, lists, and options, you will get, in most libraries, the generators out of the box. But sooner or later, you will find a type when there's no built-in generator. And it's actually a good thing. You actually want to provide your own generators for the data or value types that you use a lot in your code and in your tests. And you want to make sure they generate data which is correct for your domain. Because if the generator generates data which doesn't make sense in your domain, then even if it finds that your test fails, so what? It doesn't give you any value. You actually wanted to generate correct input data, but make your test fail. And only then it gives you some value, because it means that you probably have some kind of a bug. So providing such generators is something that you will need to do in your code, and it's fine to spend some time providing the perfect generators for your perfect types. So for example, here in jQuick, if we said we need to work with a property that works in some kind of strings, but not all strings, just a subtype or subset of strings, and a subset of numbers, then the way we do it in jQuick is we need to provide a method which returns an arbitrary. This is a generator in the world of jQuick, which provides an arbitrary of string basing on the built-in features of jQuick. So here this arbitraries.strings is something that you get from jQuick, and then on it you can invoke some static methods, so specifying char range, filtering out, specifying minimum, maximum length, and so on. And this way, mapping generators, mapping methods together, combining things together, you will eventually get the generator which will generate, for example, a customer which is correct in our domain, or a date or a future date which is correct in our domain, or a date of birth which is correct in our domain. Now, that's all fine, but since property-based testing have been around for a while, then why hasn't it ruled the world? Why do we still need example-based tests? So surely there must be some challenges or some tricky bits. Yes, and I would like to show you what are the 4 challenges which are most important in my opinion. The first one is that property-based testing makes you ask difficult questions earlier. So imagine if you write the code, when I try to follow the test-driven development, I write the simplest code, then I write the simplest test case, then more complicated code, more complicated test case, and so on and so on. But here, it's not really possible, because before I write the first line of code, I have to think what is correct data, because I have to provide the generator. So I have to ask questions like, what is the longest surname a person can have in our system? What is the older person that can have an account in our system? What is the maximum amount of money a person can spend on newspapers a day? Those are all real questions from my experience, and you actually have to circle back to your product owner and ask them this stuff, and they will say, okay, so you're pretty much done if you're thinking about edge cases, right? And you're not really, because you're just starting out with the testing. So it's something that you have to get used to because it changes this dynamic and this flow of writing tests. The second challenge is non-determinism. After all, it's some kind of random data. And we don't really like non-determinism. When something fails today and succeeds tomorrow, we don't know why. And it actually happens, it may happen that you write your code, you provide tests, property-based tests, you run them again and again, they're all nice and green, and then you push it to Jenkins and then they fail in Jenkins. Or maybe even not now, they fail in Jenkins in a week. What do you do? Well, for sure what you don't do is you don't go to Jenkins, don't say, this is flaky data, let's rerun it. No, you actually have to go there and see the test report and see what actual tricky test data the library has generated for you. And then see if it's a bug that you have made, or maybe it's a misconception about the user story. Maybe you didn't think how your system should react. Maybe it's not correct data. You have to analyze this. But you can think of it this way. It's just the library has just found a bug for you or a problem for you. And the library did it, and not the customer did it someday in a year in production. So it does shorten this feedback loop a little bit, even though it's not so deterministic. The third challenge is documenting. I don't know if you have that as well, but for me, when I try to get to know some new code that I don't know what it does, I often open the test file and read the first test case that is there. And it's often the most simple example, most simplistic way of using my method or my code. And because the brain likes concrete examples, it actually tells me much. And if in this place I had a property-based test with some sane boundaries, some assumptions, or maybe testing some bit of my code, then it wouldn't give me such a value. So this documenting way, this documenting role of example-based tests is, in my opinion, really important. And it's one of the reasons why property-based tests should coexist with example-based tests, because they are not perfect for everything. And the fourth and the most important challenge in property-based testing is coming up with properties. Because right now I have told you some properties, maybe they make some sense, but if you try to think of properties next week where you come back to your project, you may find yourself staring at a blank page. Because how do you define this property which has to be always correct, but then you cannot really repeat your production code in the test, right? Because then if you have a bug in production code, then you have a bug in the test. So you have to approach it in a whole different way. So that's actually the most tricky bit of property-based testing, but also the fun bit, because it's kind of a creative process. So that's how you should treat it, in my opinion. So it's something that you might maybe work on it with your colleagues, do some brainstorming, talk to each other about what the code does and what boundaries we could define. That's because it's creative. Maybe you want to take a walk and then come back to it later. Maybe you want to think about it in the morning when you're fresh and creative. So that's the ways how you can handle it. But also, there are smart people who have prepared some list of patterns. And we do like patterns when we stack sometimes. And this link here is something that you can bookmark and go back to it whenever you are stuck thinking about properties. It's a blog post listing various patterns, which can be an inspiration for you. So you go one by one, and then you think, do I have, for example, an invariant? So maybe there are something in my algorithm which means that something doesn't change after my algorithm runs. Maybe the length of the list doesn't change after I sort it. Or if not invariant, then maybe I have symmetry. Maybe I'm writing something to the database, and then I can also read it from the database. So then I test the two things together, and I just compare that at the end. I have the same at the beginning. So maybe I do have symmetry. Maybe I have some reference implementation. It's in the patterns, it's called Oracle, but not as a company name, but as an entity which knows everything. So if you have such a reference implementation of the algorithm, which maybe isn't so fast as your algorithm, or maybe is in a different language, in a different package, then you can compare their results to your results. And that's one of the patterns there. And actually, in my experience, I used to have such a reference implementation defined in a spreadsheet. I was doing some financial calculations, and some standard was defined by some agency by a spreadsheet. And I had to provide these calculations perfectly, but somewhere in my code. So actually what my code did, what my test did, is it generated data, put it into the spreadsheet, and then after those agency-provided macros run, then somewhere in the last tab there was the result, and I had to compare that result to my implementation. And to be honest, that was the longest story with property-based testing that I had in my experience, because it kept finding some tricky small approximation issues that I just didn't spot in my code, and I wouldn't spot even if I tried tens of examples that I could think of, because the library was unbiased. So that list of patterns, that page has many more patterns which you can consult for an inspiration when you are stuck with coming up with properties. So now, if properties are not so trivial because they make you think differently about your code and they're not good for documenting, and you know they have to coexist with example-based tests, then how should you approach it? How should you introduce it to your code base? I would like to leave you with two strategies, and you can choose which one applies better in your case. The first strategy is to start traditionally. So when you write a new piece of code, you start by writing the simplest implementation, then the simplest test case, the more complicated test case, more complicated implementation, and so on. Then you start to think about edge cases. You provide the tests for the edge cases. And when you think you have really got it all and that the code is perfect, only then you start thinking about properties, coming up with them, talking to your colleagues, and so on. And it may well be that the library will find some missing bits in the way you understand your code. Maybe you will have to circle back to your product owner. Maybe it will find some bugs for you. Maybe it will make you do some more discussions with your colleagues, with business, and so on. So that's kind of a step-by-step journey, which I think is very rewarding. And it doesn't make you just dive head-on to the properties, but you do it step by step. And the second strategy, is to provide properties just for the bits which are really important in your project, for the key parts of the system. Key components. So what does it mean, key components? It can mean the most complicated components. The parts where you don't really know what happens, maybe somehow it works, but you're not sure why it usually does. Maybe that's the right place to invest your creative energy to try to understand it with the help of properties and property-based tests. Or maybe key components means just the core value of your business. So the thing that you have to make sure it's perfect, because if it's not, maybe your client loses money, maybe your users will lose money, or they will be unhappy, and so on. So you want to make sure that you did everything you could, and with the help of properties, to make sure it's correct. So you don't have to write properties from day one for all of your code. Maybe you want to provide it only for the key components. To sum up, property-based testing are not trivial. They come at a higher cost, but at the same time, they give you value which no other kind of test can give you. Where they shine is with finding edge cases and misconceptions and the ways you didn't really think through your code and your algorithm. The most tricky part, but also the most rewarding and fun part, is coming up with properties. So at first, you may find yourself stuck, but believe me, with experience, you will get much better at it. And the key is to find the right balance. So if you find, I cannot tell you right now, everybody should have 10% property-based test, 90 example-based test, but if you find the right balance for your project, which makes sense for you, then you know that you did everything you could to make your code correct for all the edge cases you already know about, and you are somehow insured against the edge cases which the library may one day uncover for you with the help of property-based tests. And if you'd like to know more, then the jQuick documentation is pretty good. It uncovers for you more features of property-based test libraries and jQuick in general, or in specific. The second one is an Erlang blog post series, which is quite good also in explaining the properties and in teaching you to think about your code in such a way that you uncover the properties as you go. The third link is this list of patterns that you might want to bookmark. And the fourth one is a repository with examples from this presentation. So you may play around with that. Thank you very much for your time. If you have any feedback or comments about this presentation, then I will be very happy to accept them under this QR code. And if there are any questions, I think we still have 3 minutes. If not, then I'll be around. Thank you. Yeah, I see a question here. So the question is it possible to specify the seed so that the test is not so deterministic, right?
It becomes deterministic. So the random that's used to generate test data is seeded such that you always have the exact same random data that's generated.
Yes, so this is a very good question. What do we do about the randomness? And we do know that if it's randomness, then there's some kind of a seed underneath it. So actually what you can do, if you are interested in this specific set of data, then jQuick will print out the seed for you, and you can have an annotation to make kind of an example-based test out of this property-based test by making it use this seed again and another time. So that if you see that your test fails in Jenkins and you want to reproduce it to actually make sure that you fix it, then you cannot just trust on randomness. You have to actually run it with the same seed. And jQuick and the other libraries let you do that. Does that answer your question? Great. I see a question here.
Yeah, another approach. Would you put this into explicit unit tests also? If you have a failure with a certain example, that you don't want to make that fail again without running the whole seed?
Yeah, so the question is it a good idea to put such a test with a seed and make it actually an example-based test and put it in your unit test? So yes, I think it's a quite a good idea. Otherwise, if you can easily turn it into a normal unit test, then you don't need to do it. But maybe it's actually easier for you to use this seed, don't change anything, and apart from this suite which still runs properties and non-determinism and so on, have one pinpointed example with this specific seed and just have it forever in your suite. I see a question there.
Inspecting the source
Right. So the question is the framework able to inspect the data that you are working with to provide tricky data, like tricky enough, right?
Inspect the source code.
Inspect the source code. I'm not sure about inspecting the source code, but generally I would say yes. So it depends on the library, but there are some ways in which you can tell the framework or the library where it should focus on. So it knows the types inside, so it can generate the types, but you can also, for example, tell it that some combinations happen more frequently than others, or some are more important. So that's something that even more that you can do to make your test correct. But generally, the library does look at the types you have. I don't know how far you would like to go with it analyzing the source code, but we can talk about that later as well. Thank you. Okay, I guess we're out of time now. Thank you very much again.